to answer this question, what is the difference between gaining 3% for 8 years versus the other version? So sometimes it says gain 3%, a price increase each year, or sometimes it says take 3% of the original and add that for 8 years. So what's the difference, or how can I recognize the difference? So the difference here, this is from this concept was in lesson 1-4. And so in that lesson, the discussion was about linear versus exponential growth. So with a linear growth, the value after a certain time is calculated using the starting value plus a constant change times a certain number of years. So that's our description of what linear growth would look like. Where when we discuss when the problem is exponential growth, this is the value after a certain time period is calculated using the starting value times a growth factor. Raised to a power. So I'm going to put the power in superscript here. So it's a growth factor raised to a power, and that power is typically the number of time periods. So I'm going to say number of time periods or number of years. So if you're gaining 3% for 8 years, or if you take 3% of 50,000 and add that for 8 years, those are two different problems. And so what I think is best, because this isn't the full question here, is I'm going to pull over a question that shows this example. So I have this question from Connect Math. It's from lesson 1-4. And it says that a frozen pizza that originally sold for $5.05 undergoes a 5% increase each year. Find the new cost of the frozen pizza after 12 years. Round your answer to the nearest cent. The new cost of the frozen pizza after 12 years is blank. So I've got the question there, and I'm going to write down the important parts. So I've got 505 is the original price, and then we have a 5% increase each year. So when I have to decide, is this linear? Am I going to use a linear pattern? Am I going to use an exponential growth pattern? I have to first think, this is 5% increase each year. It doesn't say 5% of the original price each year. It says 5% increase each year. So if I have a constant rate, and so this right here is my constant rate, then it's an exponential growth. So I have a constant growth factor. So it's typically a percentage, constant percentage, that I'm going to write as a growth factor, then I know that I have to use the exponential growth model. Now, if it said, here's my original price, and there's a 5% of the original price increase each year, then 5% of the original is going to, I can calculate that, and that will be a constant amount. So it's not a percentage, even though they try to trick you and say, well, that's a percentage, it's going to be exponential. It's 5% of the original price. That's a constant amount. That's the same amount. It doesn't change. 5% each year is going to change because the 5% is calculated on year 1. Then the 5% is calculated on whatever the price is on year 2. And then the 5% is calculated on year 3. So you're changing that amount each year. So it's not the same amount. It's the same percentage, but each year you get a different amount. It keeps getting higher. Where if you say 5% of the original price, then that's a constant amount, and that would be linear growth. So that's how I recognize which one is which, or which one to use. So going back to my problem, let's erase this part. And I'm going to say, okay, I'm going to say $5.05, that's my starting price, times my growth factor. My growth factor is going to be always 1 plus the percentage written as a decimal, raised to the number of years. So in this question it said 12 years. I'm going to put a 12 here. So now enter this into my calculator. I can combine what's in the parentheses, enter it just like you see it here. If you're going to do it in 2 steps, make sure you follow the order of operations and that you raise it to the exponent first. Notice I worked in the parenthesis first, then I raise this to the exponent, and then last I multiply. Remember, our order of operations looks like this. So, but I could just put this in the calculator like I see it on the screen. And so let me do that now. And so after 12 years, I'm going to round to the nearest cent. This is what I have on my screen. But to the nearest cent, remember, where's the cents? That's the 100th place. That's here. So I look 1 over. And so I'm going to say $9.07. So the pizza after 12 years, that frozen pizza, is going to be $9.07. So let me type that in there. Then I'm going to hit check answer. It's going to give me a green check mark. And I'm going to move on to part 2, which now part 2 says, well, if on the other hand, the cost of the frozen pizza was increased by 5% of the original cost. So notice that 5% of the original cost each year, that 5% of the original cost will give me a certain amount for 12 years. How would that compare to your answer from part A? Round all intermediate calculations and the final answer to the nearest cent. So let me write down this one. So I've got $5.05, 5% of that. So 5% of the original, remember, let me rewrite this. That means 0.05, writing it as a decimal. The word of means to multiply, and the original pizza price was $5.05. So 5% of that means that there's an increase each year this is what I have on my calculator screen, but it tells me to round the intermediate calculations. So I'm going to round to the nearest cent. So 0.25, so 25 cents increase per year. So this is a linear pattern. So follow what I said here. Starting value, $5.05, plus the constant, 25 cents, times the number of years. So what am I going to get here? I have to do this multiplication first. This is 3. And then 505 plus the 3 will give me $8.05. So the question does not ask for the $8.05. It asks the frozen pizza would cost more or less than the 907. So it's less than 907, and I have to find that difference. 907 minus 805. It would be $1.02 less. Well, let me put that in here. Then I'm going to hit check answer. It's going to give me a green check, and then I can move on. So that's the difference. This is an example of exponential in part A or part 1, and in part 2, that 5% of the original cost means you have a constant amount each year that's added. So you got to find that constant amount, which we found is 25 cents, multiply it by the number of years, add it to the original. So that's the difference between an exponential growth pattern and a linear growth pattern.